So in this lesson I'd like to look at rational expressions, also known as algebraic fractions basically. So when you've got algebraic fractions and you want to simplify them, how do you do it? Well, there are some key skills you need to remember first. So none of these questions are algebraic fractions, none of these are simplifying rational expressions. These are the background skills you need to remember first. I'm going to call on these skills in order to do simplifying rational expressions as we go along. So first of all, recall how you do something like this. Laws of indices, right? So I need to divide the numbers but subtract the powers. So 12 divided by 3 is 4, and then when you subtract the powers, 7 take 5 is 2. So 4x squared is the answer to that one. This is also index laws, and we're going to do each one separately. So 36 divided by 4 is 9. P5 divided by P5 it's not 0, it's 1. Divide any number by itself. So P5 divided by P5 is just 1, so you don't need to write anything. You could write P0 if you like, but P to the power 0 is just 1. So the p's have cancelled out completely, and r squared divided by r cubed, that's r to the minus 1. 2 take 3 is minus 1. And recall that negative powers are the same as 1 over, they are reciprocals. So this is exactly the same as saying 9 on the top and r on the bottom. So recall you can do that kind of thing. This power minus 1 only belongs to the r, doesn't it? It doesn't belong to the 9 as well. So 9 is on the top, but r is on the bottom. You can write things like that as fractions if you so wish. The next set of skills are factorising skills. I just want to remind you of some of the weirder ones. So something like this, there's not a lot going for it, but I think it's a single bracket factorisation to begin with. I noticed that both terms contain a factor of 4. Both of them also contain an x. So let's take 4x outside as a common factor. I would have to multiply 4x by x squared, wouldn't I, to get this? 4x times x squared is 4x cubed, and you multiply 4x by 25 to get the 100, so it's just minus 25, isn't it? Because I've already got the x that I need there. If you're ever unsure of a factorisation, you can always expand it to check. So that's 4x cubed when you add the powers, yep, and minus 100x, yep, that definitely works. Okay, what you might notice now is that this actually further factorises. Initially, I only spotted that this was a one bracket factorisation, but the thing that's in here, let's make these brackets really bold, the thing that's in here, in these bold brackets, is the difference of two squares. And remember the difference of two squares, here x squared minus 5 squared is x plus 5, x minus 5 in this case. In general, difference of two squares, remember, so a squared take b squared factorises as a plus b, a minus b. That one plus that one minus that one. Here my two squares are x and 5, x squared and 5 squared. So this further factorises basically. This thing in here is x plus 5, x minus 5. Okay, so that's fully factorised down there now. You can have much more awkward factorizations like this, and that's when you've got the brackets such that it's not just y and y at the start here. You're going to have a 3 as well, because how else would you multiply the two first terms together and get 3y squared? And then you kind of hope that the number here is like a prime number or something, because if it is, then it's just itself and 1, but it's not. Unfortunately, there's a few choices for 8. In fact, there's, well, it could be 2 times minus 4, or minus 2 times positive 4. It could be 8 times positive, 8 times minus 1, and minus 8 times negative 1. So there's a few choices here. The fact that I've got to get a 10 here means that I probably can't put a big number like an 8. 3 times 4 is 12, and that's getting me close to the 10. So maybe I'll put a 4 there, because 3 times 4 will give me 12. If I put a minus, it's minus 12, and I put a plus 2, yeah, that works. That works. You heard my thought process there, and you've done lots of practice of these in the past, so that might take you a bit of time when you come to factorising these, but that definitely works, right? 3y squared, that would be minus 12y, but then plus 2y from here, which is the minus 10y, and the two last terms multiplied, 2 times minus 4 is minus 8. So it is the correct factorisation. But all I did was I stuck down the 3y and y to begin with. I thought I need a pair of things at times to give this, and I just thought about factor pairs. I didn't write them down, I just sort of said them out loud, and you heard my thought process there. I still think that factorising hideous things like this, where you haven't got just 1 y squared or 1x squared, I still think it's easier if you just look at it and think about it and try things in your head. But I did show you a method that would work before. Finally, a ridiculously easy one. You should be able to simplify 6/15 in your head, no problem. But I want to show you a slightly odd way of doing it. When you simplify fractions, you are really always doing this, but nobody ever thinks about it. You're factorising the denominator and the numerator. So you're saying, well, 6 can be written as 2 times 3. 15 can be written as 3 times 5. And then you say, have I got anything on the top and on the bottom? Factorising, remember, factorise literally means write it as things multiplied together. Factorise doesn't really mean put it in brackets. Factorise really means write it as factors multiplied together. So that's what we've done here, because we've turned it into two things multiplied together. But we've also done it here as well. Factorising doesn't necessarily need any brackets at all. Factorise 6, I've done it as 2 times 3. Factorise 15, I've done it as 3 times 5. When you factorise, there's absolutely no point whatsoever in using the number 1, because if you put some 1s in there, you don't get anywhere. Whereas the 1 times table up here is often very useful. Anyway, so I factorised the 6 and the 15, and I noticed that there's a 3 on the top and a 3 on the bottom. So let's divide top and bottom by 3. 3 divided by 3 is 1, of course. And then what's left? On the top I've got 2 times 1 is 2, and on the bottom 1 times 5 is 5. And that's the correct answer, isn't it? That if you simplify 6/15, you get 2/5. You don't normally think of it like that, but that is the process that's going on in the background. When you say divide top and bottom by 3, that's really what's going on in the background. You factorise the top and the bottom, and then you cross out any common factors. Okay, so now we've revised those sort of background essential skills, we can use them. In each case, I'm given a fraction that's got algebra in it, and I want to simplify that as far as possible. These are called rational expressions. When you've got one expression divided by another expression, that's called a rational expression. Right, so here I need my first skill that we talked about. That's the laws of indices, basically, isn't it? I could, well, you do 16 divided by 24, but it doesn't go exactly. I could divide top and bottom by 8, however. Right, let's divide top and bottom by 8. That's going to give me a 2 on the top and a 3 on the bottom. But when you subtract the powers, 2 take away 3 is minus. Or you could say, let's divide top and bottom by k squared. That's probably better, isn't it? Divide the top by k squared is just 1. Divide the bottom by k squared is just k. So I've got a k left on the bottom and I'm done. Perhaps that would have been easier to write as a factorisation first. Maybe it's overkill. So you could have written this as 8 times 2 times k on the top. And on the bottom you could have written it as 8 times 3 times k times k times k. I'm not saying you would do this, but it's a potentially correct method. I noticed that there's an 8 in the top and the bottom, so I could divide top and bottom by 8. I could divide top and bottom by k, and again, and all that's left on the top is a 2, and all that's left on the bottom is a 3k. All right, so I'm sort of using laws of indices, but I could have done it with the factorisation method as well. At number 2, if I want to simplify a fraction that's got like pluses and minuses going on, I can't do things like, all at 10 and 4, let's divide both by 2. I can't say that kind of thing. I can't say, oh, there's an x there and an x there, let's cross those out. It doesn't work like that. They have to be multiplied together, but these are sort of subtracted. So let's factorise, because when you factorise, you're writing it as things multiplied together, and then you can cancel common factors from the top and the bottom. So this top one is just a one bracket factorisation. The thing that's in common here is 5, and that's 5x minus 2. The bottom is the difference of two squares, so that's x plus 2, x minus 2. And then you'll notice that you've got this common factor of x minus 2 on the top and the bottom. So let's divide top and bottom by x minus 2. And all that's left is a 5 on the top and an x plus 2 on the bottom. So that fraction there simplifies to that fraction there. When you're writing your workings, I am expecting you to write something with one neat line through it. That's not messy or horrible. That's the traditional convention of how you show your workings. So don't completely obliterate it, but please also don't try doing it all in your head and sort of magically going from here to here without any crossings out, just because you think it doesn't look neat or something like that. I do come across that strange situation sometimes. So this really is the traditional way of doing it. Hopefully you're used to that by now, but just in case there's any of you hanging around that are still suspect about the idea of putting a neat line through your workings, that's the correct way of showing cancellation. Okay? Right, number 3, these are just harder factorizations basically, but it is still the method to factorize everything in sight. So on the top, two things at times to make minus 21 but add to give minus 4, 7 and 3 with some sign. So what's that going to be? X minus 7 and x plus 3. Okay, they're the pair that multiply to give minus 21 but add to give minus 4. Denominator, oh, it's a pain. We've got a 2 going on, so this is 2x and x. I need two things at times to make 7, or minus 7, but eventually make minus 13. So in that case, I will put the 7 here, because 2 times 7 is 14, and that gets close to the 13. So the 7 there, the 1 there, it has to be. Then I need to get the signs right. It needs to go pretty negative, so let's put the minus there, so I go all the way down to minus 14x and then add 1 more. So that's the correct factorization. But you actually had something of a clue. They were asking you to simplify this. They wouldn't ask you to do it if it didn't simplify. They're not going to ask you trick questions. So when you're trying to deal with the bottom, you sort of had the clue that at least one of these is likely to be a factor. So you could you'd know that one of these is likely to be the bracket down here. It's not guaranteed, but it's likely, isn't it? So you had a bit of a hidden kind of clue there. Okay, now you might notice there's an x minus 7 on the top and the bottom, so let's divide top and bottom by x minus 7, and then all that's left, you'd normally write this underneath, but I've run out of space. I've got an x plus 3 on the top, and a 2x plus 1 on the bottom. So this whole rubbish here simplifies to this, and it was crucial that we factorised everything in sight first of all. Finally, number 4, this one here is much like your exam question. The one you had in the exam had a divide sign here, so you had to do KFC as well, and actually that was the source of the mark for most of you. Lots of you did remember to do KFC but weren't sure what else to do. So it's factorise everything. I've also got one other little neat trick in here that sometimes helps you. So here goes. X squared minus 64, that's the difference of two squares. So that is x plus 8 and x minus 8. Down here, that's a one bracket factorisation. The only thing that's in common here is x. So I can pull an x out. And we've got 4x minus 1. Over here, well, this could be either a sort of 2x and 2x type situation, or it could be a 4x and a 1x situation, but I'm willing to bet it's probably going to be this one, because look, I've got a 4x thing down here. It's probably even 4x minus 1, and looking at it, 4x, if it is 4x minus 1, then I just put a 2 there, and that works, doesn't it? If I just put a 2 there, you'll see 4x squared plus 8x, then take away 1, yep, that's my 7x, and that's a minus 2. So I was using the fact that there was probably going to be one of these factors, not necessarily, because it might have been one from down here instead. And then finally, this is a one bracket factorisation. The thing that's in common here is just the number 2. So let's pull a factor of 2 out. 2 times 8 is 16, and 2 times minus x is minus 2x. Now, it doesn't look like a lot's cancelling out here, but I have got that will cancel with that if I divide top and bottom by 4x minus 1. Remember, it doesn't matter which fraction it is. As long as it's something on the top and something on the bottom, it doesn't matter if it's a top of one of the fractions and a bottom of the other one. And then it looks like that's all. However, I'm going to do something kind of clever here. Let's keep this one the same. So at the moment I've got x plus 8, x minus 8, and an x on the bottom, and that's cancelled out. Over here I've got an x plus 2. Now I said earlier that the thing that's in common here is 2. So one bracket factorisation, and the thing that's in common is 2. So I pulled a 2 out. But when I did that, it didn't match with any of the others. Notice that I could have pulled out a minus 2 instead. So I'm sort of refactorising this thing now, because when I factorised it like that, it didn't really help a great deal. So let's pull out a minus 2 instead. Now, minus 2 times by minus 8 gives us positive 16, and minus 2 times positive x, that gives us the minus 2x that we wanted here. And it may or may not be obvious to you that actually this is the same as this one. Okay, x take away 8 and minus 8 plus 8. These are the same thing, because you can swap the order of an addition round if you want to. These are the same thing here. It might take you a while to convince yourself that's definitely true. So, you know, I'm trying to convince myself that a number take away 8 is always exactly the same as minus 8 plus that number. Off the edge of the page, sorry. I'm just trying to convince myself that a number take away 8 is always the same as minus 8 plus that number. Convince yourself it is. Suppose I chose the number 10. Okay, 10 take 8 is 2. Minus 8 add 10 is 2. I could play that game all day and it would be the same. So now I can say that that cancels with that. And then what have I got left? Well, on the top, I've got an x plus 8 and an x plus 2. And I'll actually do the multiplication of the fractions here. And down here, x times minus 2 just a minus 2x, like so. There's no need to expand that now. That's completely fine as your final answer. So there's a few examples for you of simplifying rational expressions or algebraic fractions, and you always have to factorise everything first. Remember, some of the key skills that are involved are these, where you might need to do stuff like index laws, and you might need things like difference of two squares. You might need these awkward factorizations here. You might need one bracket factorizations, and all sorts. Best of luck then.